I'm going to start with a question for Laurence and Ramzi, actually. What needs to happen because I was thinking the whole time you're talking, this is super cool, this is amazing, this is something everyone can benefit from and everyone can be part of. So what needs to happen for this to become mainstream?
So I guess my answer is we looked at the curves of technology adoption. Dishwashers had a hiccup in 1940 and then ramped up in 1960. Is it to do with the quality of the marketing officer, the chief executive officer, how much investment they raise, all those things?
Okay.
Ultimately, for us to be mainstream, I need to be able to build the biggest flooring factory in the world. And to be able to do that, I need to have a lot of capital. Now, if anyone's got $1 billion, I can do it. But at the same time, I need to prove that we can deliver. So you've got to do it in each stage. So we just got backing in the UK by the 2 richest men in the UK who've put in less than 10 million. But I need to go bigger and bigger and bigger. So ultimately for us, it's about getting the company valuation right, proving we're a team that can execute. Everyone loves a story from an entrepreneur, but it's very different actually executing on ground level. It's nowhere near as glamorous as what it looks like on screen. It's lots of boring hours in front of a desk. So I think it's about capital and proving it as a tech team to be able to really make something mainstream.
Ramzi, what do you think?
I think there's 2 things. One is policy. I think there's a lot of examples where regulation and incentives have been put in place to actually encourage innovative products that's good for the environment. And the second, I think it's also a mentality. I mean, in the construction world, actually, there's this, I should have put it, where the construction is actually one of the least, so the industry that uses technology adoption the least in the world. And I think that's just a mentality. I think a friend of mine once said, the amount of sensors on a bridge is very, very little, but you look at a sensor on a BMW that's on the bridge is huge. And even though the bridge costs a lot more than the BMW, which I think is very relevant to today's talk with MIT. So I think those 2 answers, culture and policy.
Newsha, I want to ask you about something that we discussed yesterday and today, a point we touched upon in different sessions, which is privacy. Did you face any privacy issues so far? And if not, do you think that progressing, especially when you talked about beyond opioids, what fields you can get in, drugs, you can know illnesses, etc. So do you think privacy is something that will be an issue for you?
Yeah, so privacy is definitely an area and an issue that we as a company are tackling head on. We want to lead the conversation around how wastewater epidemiology is implemented in a very thoughtful way rather than being reactive to it. So first of all, I didn't mention this in the talk, but when we select our sampling sites, we do not sample an area that represents less than 5,000 people. And so that is the most de-aggregated level of our data. When you look at data that is being used by the healthcare industry today, whether it be pharma or insurance, it's a process of anonymizing and aggregating up sensitive data, which I think we know now that can be very easily de-aggregated again. And so for us, it's very important to understand that the most de-aggregated level is at that 5,000 person level. I think that's the beauty that we see in sewage or in wastewater is that it's naturally mixed. It's an environment that is naturally, everybody contributes to. It's a very democratic way to understand the health of a community.
Great. Do we have any questions? We have one here and then. Mike, please.
Thank you. This is impressive what you're doing. Laurence and Newsha, in terms of older infrastructure, does that at some point limit the ability of your work? Older cities, older infrastructure?
Yeah, so does the infrastructure impact what we're doing. I think in London, I've gone to install Pavegen in the heart of Oxford Street. We've removed a paving slab, and underneath it, the tube is sticking out into the paving slab. And the guy's got the chart, and he says, it's meant to be 8 meters away, but London works on a tolerance of 8 meters sometimes. It was put in the 19th century. You know, it's a mess. Nothing is right. No cable is in the right place. So it's really important that you can retrofit a technology to an existing urban space. So what we've done is we've made sure that the depth is about 100 mil, which also, exactly, so 10 centimeters, 100 mil. I thought I was in America for a second there. I was going to try converting to inches. And what we do is you can install it anywhere. Usually people have a depth of kind of this much in flooring. So when we say we want this much, it's really easy to install. You can put it inside and outside. Outside drainage is like such a big challenge in the world. Drainage is a problem. I've heard a lot that the British designed the drainage in the UAE and they didn't realize about the sand, and then it apparently all floods a lot. So British engineers failed. So I'm sorry for that years ago. So I think you've got to be ready to retrofit, and it's got to be really straightforward to do it in the most complex, challenging environments known to man, which is what you're going to find, you know, from Hong Kong to Bangkok to London and Dubai.
Mm-hmm. Yeah, I'd have to agree with that. I think the most successful technologies are going to be those that can be implemented in our existing cities. You know, as much as urban population growth is growing globally, and we are building brand new cities every year, we're not going to rebuild Paris, or we're not going to rebuild London. So I think the most profound and the most impactful technologies will have to have the capability of integrating into our existing cities. With us, I mean, we're lucky in that we first prototyped and developed this in Cambridge, Massachusetts, which actually, fun fact, has the oldest wastewater infrastructure in North America. It's actually brick-lined on the inside, so it's very bizarre. And so for us, that presented challenges in, you know, very similar to sewer lines weren't exactly where they needed to be. The sewer line should be separated, and yet it's mixed with storm and wastewater. So when it rains, you know, we have flooding, or we have a lot of influx of rainwater. And so we had to, on the back end, develop our technology to correct for that. So we actually have the analytics capability of correcting for dilution, for example. So that was something which was very much like a real world you know, scenario that caused us to adapt our technology to be able to correct against dilution from things that range from rainwater all the way through to shower and dishwasher water. But of course, you know, it would be the easiest to implement this from day one in a brand new city, in a brand new infrastructure.
We have another question.
From the Federal Authority for Nuclear Regulation. I have a comment for Mr. Ramzi.
Yes.
To support what you just said. There is a book authored by 3 prominent British construction engineers titled, "Why is the construction industry so backward?" That's a comment. A question for Laurence. Have you thought of using artificial light to store and regenerate electricity?
So have I thought about artificial light to store and generate electricity? One thing we've done is we've looked at, could you integrate a solar hybrid into the floor? So if you look at the UAE, when it's really hot, no one's walking outside at all in the heat. So what if you could still make it produce power in daylight hours, and then in the evenings, when people do walk on it, you've got this hybrid solution. So we're really fascinated about putting those two technologies together. It's a big challenge because you've got to make a solar panel you can walk on, and no one's absolutely nailed that technology yet. In terms of reusing it, you know, with artificial light, I think LEDs are getting really efficient. They call it the efficacy. The efficiency of LEDs is going through the roof now. You know, companies are paying billions of dollars in research every year. And there is potential to maybe recycle that. Not saying I'm that close to at all, but definitely solar floors is something I see big potential in the future, especially here. Yeah, certainly. I think ultimately nothing beats the sun. The sun, direct sunlight is here and artificial is down here. And I think for harvesting, so for example, if we were going to use your sensors in a drain, and there was some form of light, that would probably be enough to power the sensor. But we look at higher power applications. So if I'm actually trying to run, like charge an electric car, it may take 200 years of light here, whereas I might only need 3 minutes of light to send a signal to your sensor network to then say something's happened. So I think it's all about the application. And in the future, there's definitely more development happening, because I need cheap storage that I can buy. I need the Tesla Gigafactory to get online quickly to give me cheap storage, and then that will help us be more viable in the market.
We have room for one more question.
I've actually 2 questions. One to Laurence about what do you think? Ramzi talked about adoption of new technologies. What do you think is standing between you and a hockey stick kind of adoption for a technology that sounds brilliant, at least in the way that you described it? I mean, it sounded a bit. Is going to be a bit on the high maintenance side because of the mechanical aspect to the pavement. But beside that, what's standing between you and scaling and growing? The question to Ramzi is also similar to that. It looked like it's complicated 3D printing of cement 3D printing. So if it's for a museum or a fancy building or a fancy hall, I mean, that's great for now. So how far are we from mainstream adoption of 3D printing for cement?
Great. So do you want to start?
Go ahead.
Okay. So what's stopping us scale, and how do you scale quicker? So I'll give you an example. We're working on a project that will see 80,000 square meters of Pavegen utilized for a new smart city happening in Nevada. Okay. Now, for me to ramp up my production, which is about capacity, so it's about how many can I make in a short period of time, I need to, one, make sure the product works really well. You cannot afford any product failures, because it's game over if anything goes wrong in that level. You've got to build test equipment to test the test equipment, and then test equipment to test the test equipment to test, and it goes on and on and on. And we want to do it in a really sustainable way. So I think we've learned a lot in the 1,000 prototypes we've created since day one. The first product, it had a light on it. And I realized that when women walked on the product, they didn't walk on the lights because they thought there was a camera there. Who would have known? So we phased that product out. So a lot of user testing is important, not just physical and mechanical characteristics, but almost like how people connect with it. So I think that's one. Two, ultimately, it's about raising capital to allow us to do that. So we just closed funding in the UK, small amount, but people like SoftBank need to really scale up, and obviously they've had a bit of a tough time recently with their recent work with WeWork. But we need big players like that to commit, and so we are looking at a next round of funding that will allow us to make it mainstream. But ultimately, people never look to the floor to generate energy. Think how long solar's taking. In 1960, people were like, I don't know about solar. Is it on every single building in UAE yet? Well, not quite on every building. Why not? So I think we need some education in the market so it can be absolutely everywhere. That is funding, is education, and user adoption as well.
So your question was will 3D printing with concrete be adopted, and how? If so, how long? Right? That's correct. And because you said it looks complicated. Have you seen the first mobile phone? It was pretty large and pretty inconvenient, and almost didn't do the serve. So what you're seeing here is a first prototype. In my opinion, 3D printing of concrete will happen. It will be the future, and it's just a matter of two things. One is, as I mentioned, honestly, policy and construction firms actually have a culture shift and adopt it. I do admit that the technology has to mature a little bit. We already see a lot of robotics and a lot of prefabricated factories and facilities. So yes, it'll be there. I'd give it 5 to 10 years for it to be quite significant around the world. Yeah. I hope that answers your question. Yeah.
We're unfortunately out of time, so thank you so much. This has been very interesting.